US just revealed a hypersonic aircraft that is reportedly faster than the iconic SR-71. Rumored to reach speeds exceeding Mach 5, this advanced aircraft has sent shockwaves across the world. With China and Russia also racing to develop their own hypersonic platforms, the US has begun the development of another mind-blowing aircraft that has taken the global defense community by surprise, sparking fears of a new arms race. Is the SR-91 Aurora truly the fastest jet in the world? What other interesting aircraft is the United States working on? Join us as we unveil the capabilities of the new SR-91, the fastest jet that has never been seen before. The United States is renowned for having more stealth aircraft than any other country in its possession, both in numbers and types. It currently uses 3 known stealth aircraft models and is developing at least 3 more. For each stealth aircraft like the F-22 Raptor, F-35 Joint Strike Fighter, or B-2 Spirit, there are others that never made it to active use. Some were canceled, while others were created for testing new technologies or systems, not for combat. Due to the secretive nature of stealth technology, new stealth aircraft are usually developed in complete secrecy. For instance, the F-117 Nighthawk was in service for years before the US government admitted it existed. Many prototypes, technology demonstrators, and even aircraft intended for service, but later canceled, remain secretive even long after they are retired. The Pentagon often funds the classified development of advanced technologies, commonly known as black programs. Today, the most secretive projects are called special access programs, where information is highly restricted. Within SAPs, there's an even more secret level known as unacknowledged SAPs, where details are so confidential that they are shared only verbally and at the highest government levels. Despite the mystery surrounding these top-secret aircrafts, today we'll explore one of the fastest jets that has ever been developed. And no, it's not the SR-71. The SR-91, also known as Aurora, is the popular name of a hypothesized American reconnaissance aircraft. It is believed that SR-91 Aurora is capable of hypersonic flight at speeds of Mach 5+. The Aurora legend began when reports surfaced that Aurora was accidentally mentioned in the US budget, allocated for black aircraft production. Aviation Week suggested Aurora referred to a group of advanced aircraft rather than just one. Ben Rich, former head of Lockheed's Skunk Works, later mentioned that Aurora was actually the code name for the stealth bomber competition, which led to the B-2 Spirit. As time passed, experts believed the US could develop a Mach 5 aircraft to replace the SR-71 Blackbird. Some people claim to have discovered unaccounted funds in the defense budget, possibly directed toward secret projects. Reports also emerged of unidentified aircraft sightings in California and the UK, featuring strange contrails, sonic booms, and other phenomena. These sightings were often linked to the rumored Aurora aircraft, despite the lack of concrete evidence. An engineer named Chris Gibson reported seeing a triangle-shaped aircraft refueling from a Boeing KC-135 Stratotanker, accompanied by F-111 fighter bombers while working in the North Sea. He observed the aircraft and later sketched what he saw. When the sighting was made public, British officials denied knowledge of such a black program, though they admitted they wouldn't be surprised if it existed. Group Captain Tom Eales of the RAF also reported seeing a mysterious aircraft over his house near the Mildenhall USAF base. The engine noise was unlike anything he had heard before, and when he made inquiries, he was told to stop immediately. Eales believed this was a new stealth aircraft called Aurora. Around the same time, there was an incident at Boscombe Down involving an emergency landing of an unknown US aircraft, which was quickly covered and removed with secrecy. A crash at RAF Boscombe Down was later connected to black missions. The site was heavily guarded, and the base was closed to all flights. Some suggested the crash involved a towed missile decoy rather than a secret aircraft. Also in Southern California, a series of unusual sonic booms was detected by sensors tracking earthquakes. These booms didn't match those from the space shuttle or other known aircraft, leading some experts to believe they came from a high-altitude, high-speed aircraft. However, nothing specific tied these events to any particular aircraft, though they fueled the Aurora legend. Now, to a very important question, did the Aurora succeed the SR-71 as the world's fastest aircraft? Well, let's explore the details of the Blackbird. The Lockheed SR-71 Blackbird was a high-speed, high-altitude reconnaissance aircraft designed by Lockheed Corporation's Skunk Works division in the 1960s. It was built for speed and stealth, capable of flying at over Mach 3, which is 3 times the speed of sound, and at altitudes of 85,000 feet, making it one of the fastest and most advanced planes ever created. The SR-71's sleek, black design earned it the nickname Blackbird, and it was also known as Habu in some circles. The Blackbird evolved from the earlier A-12 reconnaissance aircraft, with Clarence Kelly Johnson, a brilliant aerospace engineer, playing a key role in its innovative design. Unlike its predecessor, the SR-71 was longer, heavier, and featured a 2-seat cockpit. It also carried advanced equipment for gathering intelligence, including sensors, radar, and high-resolution cameras. Its primary job was to gather intelligence at speeds and altitudes that made it nearly impossible for enemy forces to intercept. The SR-71 was built to fly at speeds with a 2-person crew sitting one behind the other. The pilot in the front cockpit flew the plane, while the reconnaissance officer in the back operated the surveillance systems and navigated the mission. This aircraft was one of the early attempts at stealth design, created to have a small radar signature. The plane was painted a very dark blue, almost black, to help manage its internal heat and blend in with the night sky, earning it the nickname Blackbird. Though the SR-71 had radar countermeasures, its best defense was its incredible speed and altitude, which made it nearly impossible to catch. With its low radar visibility, enemy missiles had very little time to detect, track, and hit the plane. By the time a missile was launched, the SR-71 was often already out of range. Even if a missile managed to get close, the SR-71 could simply speed up, and the missile would run out of power trying to catch up. The plane could also change speed, altitude, and direction, making it hard for enemy radars to lock onto it. The SR-71 flew faster than the Soviet Union's best interceptor at the time, the MiG-25, which also couldn't reach the SR-71's altitude. Throughout its service, no SR-71 was ever shot down. The SR-71 was powered by 2 powerful engines called Pratt and Whitney J58. These engines were designed to be very efficient at high speeds, especially around Mach 3.2, which was the Blackbird's usual cruising speed. At takeoff, the afterburner provided 26% of the thrust. As the speed increased, the afterburner took over completely, providing all the thrust at Mach 3. The maximum speed of the SR-71 was limited by how hot the air entering the engine could get, with the engine compressor only certified for temperatures up to 800 degrees Fahrenheit. To start the SR-71's engines, a special cart with 2 car engines was used. This cart was placed under the engine and connected to a drive shaft that spun the engine up to 3,200 revolutions per minute, at which point the turbojet could start on its own. Once one engine was started, the cart was moved to the other engine. Later, a quieter pneumatic system was developed for use at main bases, but the old start carts were still used at smaller airfields. This extremely fast aircraft used a special fuel called JP7, which was hard to ignite. To start the engines, a chemical called triethylboron was used. This chemical ignited on contact with air, creating a green flame that was often visible during engine starts. The fuel also helped cool the aircraft, including the pilot and electronics, since an electric starting system wasn't possible due to the limited cooling capacity. On a typical mission, the SR-71 took off with only a partial fuel load to reduce stress on the brakes and tires. It would then climb to 20,000 feet in less than 2 minutes and reach its cruising altitude of 80,000 feet in about 17 minutes, using a third of its fuel. Despite a common myth, the SR-71 didn't refuel immediately after takeoff because of fuel leaks. Rather, refueling was needed because the plane's top speed was only possible with aerial refueling. The SR-71 often needed to refuel in the air during long missions. Supersonic flights usually lasted about 90 minutes before refueling was necessary. Specialized tankers called KC-135Q were used to refuel the SR-71. These tankers had modified refueling boom and special fuel systems to handle the different fuels needed by the SR-71 and the tanker itself. To help pilots during refueling, the SR-71 had a special display that projected a subtle horizon line across the cockpit instruments, giving the pilot clues about the plane's attitude. Northrop Corporation's electronics division, Nortronics, developed an advanced astro-inertial guidance system for the SR-71, based on technology from earlier missile projects. This system corrected navigation errors by tracking stars through a special window in the aircraft's upper fuselage. The ANS used a digital database of stars to navigate accurately, even at the SR-71's high speeds. It could control the plane's altitude, position, and even direct cameras and sensors. The system was so precise that it limited the aircraft's drift to just 1,000 feet off course at Mach 3. The SR-71 carried various sensors and payloads, including advanced cameras, radar systems, and electronic intelligence equipment. These sensors captured high-resolution images and electronic signals during missions. The plane had a range of cameras for different tasks, from wide-area imaging to detailed close-ups, as well as side-looking airborne radar and later a more advanced radar system called SR-1. The SR-71 was also equipped with electronic countermeasures to protect against enemy missiles, including jammers that could confuse missile guidance systems. To ensure the crew's safety at 80,000 feet, where regular oxygen masks wouldn't work, the SR-71's pilots and reconnaissance officers wore specialized pressurized suits. These suits were essential for surviving in case of ejection at high speeds and altitudes. The cockpit was pressurized and cooled to keep the crew comfortable, despite the extreme heat generated by the aircraft's Mach 3.2 speeds. The cooling system even used the fuel as a heat sink. During long missions, the crew had access to food and drink through specially designed containers and straws that could be used with their helmets on. This allowed them to stay nourished and hydrated while flying for hours at a time. Despite its retirement, the SR-71 remains a legendary aircraft, holding the world record as the fastest air-breathing manned aircraft, a title it has held since 1976. Its legacy continues with the development of a new UAV, the SR-72, which is expected to take to the skies by 2025. The SR-72, also known as the Son of the Blackbird, is being designed with more advanced capabilities than the Blackbird and will be built with advanced materials like carbon-carbon composites. But it gets even better. These materials can handle more extreme heat than the titanium skin used on the SR-71. Also, as stated earlier, the Son of Blackbird is expected to have great speed, stealth, and versatility. The prototype, if not already in operation, will include advanced avionics and possibly AI-assisted systems for autonomous operations, which earlier hypersonic aircraft did not have. A key feature of the SR-72 is its ability to reach hypersonic speeds up to Mach 6, which is considered to be much faster than the Blackbird's top speed. This speed allows it to outrun missiles and avoid current air defense systems, which have given the United States an advantage in reconnaissance and possible strike missions in heavily defended areas. Lockheed Martin is working with Aerojet Rocketdyne on a special turbine-based combined cycle propulsion system to help the aircraft achieve a cruise speed of over Mach 6. While there are engines that can power an aircraft at hypersonic speeds, they can't be used during takeoff and landing. So the Son of Blackbird needs an engine that can handle both. The turbine engine will provide thrust until the aircraft reaches Mach 3, then the dual-mode ramjet will take over to power the flight at hypersonic speeds. To reduce drag, the aircraft will use a single inlet nozzle for both the turbine engine and the ramjet. This new mysterious aircraft's abilities are important for major power conflicts. Its fast intelligence gathering and strike capabilities support the U.S. national defense strategy, which focuses on being ready for intense conflicts with countries like Russia and China. Its speed and stealth make it a crucial tool for strengthening air defenses. Its development shows a strategic change in U.S. military planning, moving towards more adaptable and dynamic platforms that can operate in complex future battlefields. This change aligns with the Pentagon's priorities for modernizing space, cyber, and autonomous technologies. However, stealth technology might not work well for an aircraft like this because radar-absorbing materials may not handle high temperatures. The jet's large infrared signature would also make it hard to hide. The aircraft might leave a trail detectable by radar, like the SR-71. But with its amazing speed and ability to quickly leave an area and outrun most non-hypersonic missiles, these issues are mainly theoretical. As for weaponry, bombs and conventional missiles aren't suitable for an aircraft like this, since they could collide with them after launching. And to avoid such deadly occurrences, The son of Blackbird will be equipped with laser systems instead of other weapons. The aircraft is currently equipped with an enhanced version of the Laws, which has a power output of 350 kilowatts and is capable of cutting through 5 inches of metal with its beam. However, the main advantage of using laser weapons is their ability to be integrated within the aircraft's structure and deployed when necessary, ensuring the aerodynamic performance of the aircraft to achieve hypersonic speeds. Another intriguing feature of the SR-72 is its cockpit design that is invisible when viewed head-on, similar to the X-59 that is being developed by the Skunk Works division. Additionally, the illustration of the son of Blackbird on Lockheed Martin's website revealed a port on the upper part of the fuselage, which is typically used for astronomical navigation systems. This design element is affectionately referred to as R2-D2 in reference to the renowned droid from the Star Wars universe. Like its predecessor, the SR-72 would also feature the most intelligent sensors and the highest quality cameras to take photos that cover 100 miles in each shot. However, there's more to the SR-72 than just its capabilities. Intriguing? Yeah, let's get into it. The SR-72 as a potential candidate for the future generation NGAD fighter of the U.S. Air Force is slated to be fitted with some of the most advanced technologies the world has seen. According to the Air Force's biennial acquisition report covering the fiscal years 2019 and 2020, the NGAD fighter would maximize its stealth features by taking an overall triangular shape, internally holding its payload, and having no distinct tail section, also known as vertical stabilizers. It is the first fighter in history to be unveiled with such a revolutionary design. Vertical stabilizers had always been required to keep an aircraft airborne until the concept of active flow control came into life in the B-2 Spirit. Active flow control uses computer brains on board to constantly adjust the flow around the aircraft to keep it airborne, similarly to how birds fly. This would result in a top-level stealth aircraft that comes at a price. The SR-72 would be capable of spotting targets, friends, and points of interest from tens of miles away, and also attacking them with precision. The sensors that make this possible come with maximum connectivity, and thus the ability to share their data with every other member of the fleet, whether it is a 6th-generation aircraft or not. In order to keep every member of the United States fleet connected to relevant information in real time, the U.S. would do away with radars mounted on aircraft and instead make use of electronically configured smart skins integrated into the aircraft's fuselage. This technique would result in increased sensor sensitivity as well as network adaptability. It would also aid with making communication easier across the fleet and ultimately improve remote control. Open architecture, laser weapons that can take out targets with unrivaled precision, a mix of high-performance guns, missiles, AETP engines capable of subsonic, transonic, and supersonic flight that cost over $6 billion to develop, loyal wingmen, top-of-the-line electronic warfare countermeasures, avionics, and communications are only some of what to expect on the fighter. But despite the already advanced features that this aircraft boasts of, decades of history have taught not only the United States, but other nations that an aircraft will always have room to be better, no matter how advanced it already is, especially with near-peer adversaries getting more and more near-peer. As a result, the SR-72 will come with an open architecture that enables it to take on new upgrades easily and quickly. All of these would combine to create an aircraft with an estimated unit cost of $1 billion and a top speed of Mach 6, the closest thing today to a truly hypersonic aircraft. There have been various speculations and reports about the SR-72's development timeline. In 2017, Lockheed Martin claimed the combined-cycle hypersonic engine was ready for real-world application. The company suggested that a single-engine demonstrator could begin flying by the early 2020s, with a target of 2030 for a twin-engine platform to enter operational service. With the escalating geopolitical tensions among world powers, the United States' decision to unveil the new powerful F-15EX comes at a crucial time. With over 50 years of service, This fighter jet has been a symbol of the U.S. aviation strength, and now it is back with renewed strengths. This fighter is ready to dominate the skies and take on modern threats. What are the key improvements in the F-15EX? What makes it more advanced than earlier models? Join us as we unveil the new F-15EX Eagle fighter jet, with capabilities that has sent shockwaves across technologically advanced countries. During the Cold War era, the world was concerned with bolstering their country's defense system, investing in the creation of unrivaled military arsenals. However, in July 1967, the Soviet Union was the first to shock the world when it revealed its latest weapon in the sky at an air show near Moscow, the formidable MiG-25 Foxbat. This aircraft was unlike any other. It could fly at a top speed of Mach 2.83, has a strong radar, and can carry up to 4 air-to-air missiles. Its intriguing abilities were discovered when Viktor Belenko, a Soviet MiG-25 pilot, flew to Japan and left the Soviet Union. After studying the aircraft, experts found that it had a basic but effective design, using vacuum tube electronics, 2 big turbojet engines, and only a small amount of high-tech materials like titanium. With its 2 powerful engines, twin vertical tails, this jet quickly became the talk of military circles. As an interceptor, the MiG-25 typically can carry 4 R-40 long-range air-to-air missiles. These missiles come with either an infrared seeker or a radar-guided seeker and can hit targets up to 35 to 60 kilometers away if they are flying high and coming toward the plane. The Soviet Union interceptor could also carry a fuel tank under its body, and it was capable of dropping unguided bombs in a basic strike role, using the same system designed for nuclear weapons. Since these bombs weighed no more than the R-40 missiles, the aircraft's performance was not affected. At high altitudes of 20,000 meters and speeds above Mach 2, the plane could drop a 500-kilogram bomb several kilometers away. In theory, the MiG-25 could fly faster than Mach 3 and reach heights of 27 kilometers. However, its engines would overheat and get damaged at these speeds, so it was limited to Mach 2.83. The plane's regular cruising speed was Mach 2.35, using a partial afterburner. The maximum speed of Mach 2.83 could only be maintained for about 5 minutes to avoid overheating. If the airframe temperature reached 290 degrees Celsius, a warning light would turn on and the pilot would have to slow down. Flying with a partial afterburner at altitudes of 19,000 to 21,000 meters gave it a range just 230 kilometers less than when flying at subsonic speeds at lower altitudes. Without using the afterburner, the plane could fly up to 12,000 meters. However, its engines were not fuel efficient at subsonic speeds because they had a low pressure ratio. The engines consumed 1.12 pounds of fuel per hour per pound of thrust during cruise and 2.45 pounds with afterburners, which was worse than the F-15 Eagle's engines during cruise, but similar when using afterburners. The capabilities of this aircraft was enough to send shockwaves through the U.S. Air Force, which soon realized their need for a new fighter to dominate the skies, something they hadn't built since the legendary F-86 Sabre, a transonic jet fighter aircraft of the 1940s. By December 1967, the race was on. General Dynamics and McDonnell Douglas were given contracts to create new designs for a superior air combat fighter, one that could outperform any Soviet jet. After an intense competition, McDonnell Douglas secured the F-15 contract in December 1969. Despite no fly-off to prove its worth, many doubted the decision, fearing cost overruns and delays. But those fears were eventually forgotten when this aircraft went on to become one of the Air Force's most successful fighter jets. The Eagle had its first flight in 1972 and became operational in 1976. Since then, it has been very successful, winning over 100 air flights without any losses recorded, mostly thanks to the Israeli Air Force. Initially, the air fighter was built mainly for air warfare, but it is also equipped with the ability to perform ground attacks with mind-blowing precision. But this feature was not used as much. In war, the presence of friendly troops often means pilots need to see their targets before attacking. To this effect, the F-15 has a large radar. The jet is 64 feet long and 43 feet wide, wider than a tennis court. It has 2 engines, giving it more power than the single-engined F-16. The F-15 has a metal body with strong wings that stick out at shoulder height. The wings are shaped like a triangle with a 45-degree front edge. They have control flaps on the back, but none on the front, keeping the design simple and light. The wings are thicker near the body and thinner at the tips. Its tail is made from metal and composite materials, with 2 tail fins built from aluminum and a honeycomb structure covered with boron composite. The horizontal tail parts are also made from composite and move independently to help with certain maneuvers. The design of the F-15 is quite sophisticated. It has a brake on top of the body for slowing down and 3 wheels that tuck away during flight. Its 2 Pratt & Whitney engines with afterburners give extra speed and are fed air through adjustable front openings. The cockpit is high up at the front with large windows for a clear view. In the 1960s, the jet started using advanced titanium parts made with a special process. This aircraft is renowned to be very agile because it has a low weight-to-wing area ratio and a high thrust-to-weight ratio, letting it turn tightly without losing speed. It can climb to 30,000 feet in about a minute. Its engines sometimes produce more thrust than the plane weighs, allowing it to shoot straight up into the sky. Being designed for one person to handle in air combat, the basic version has 1 seat and focuses on air combat superiority. The B and D models have 2 seats for training, but can still fight. The E model has 2 seats, with the second for a crew member to manage weapons. One special feature of the F-15 is that it doesn't have turkey feather covers on its engine nozzles. These were removed because they caused problems and increased air resistance by 3%. In 1983, an Israeli F-15D pilot, Zivi Nadivi, safely landed the plane after losing most of 1 wing in a collision. He controlled the damaged jet with maximum engine power and landed at twice the normal speed. Tests later showed that control was only possible within a small range of speeds and wing angles, leading to research on flight control systems that adapt to damage. The F-15's avionics system includes a head-up display, advanced radar, guidance systems, communication tools, navigation systems, and electronic warfare equipment. It can also identify friend or foe aircraft, trick enemy radar, and process information with a central computer. The HUD shows important flight and targeting info in front of the pilot, so they don't have to look away during combat, even in different lighting. The jet uses advanced radar to detect targets above and below, ignoring ground disruptions. This radar tracks fast-moving objects from far away to close up and helps the pilot accurately aim weapons. In close combat, it quickly spots enemies, and the info shows up on the HUD. The electronic warfare system warns of threats and can disrupt enemy tracking. Later, the radar was upgraded to an electronically scanned array version in the APG-63 V2 and V3 models. This radar can quickly track multiple targets and work with the jet's weapons, improving the performance of missiles like the AIM-120 AMRAAM. The F-15 can carry many air-to-air weapons and has an automated system to help the pilot use them safely. The system shows info on the HUD and controls on the engine throttle or stick. When switching weapons, the HUD updates with the new info. This aircraft can also carry a specific range of missiles, like the AIM-7 Sparrow or AIM-120 AMRAAM missiles on the lower fuselage, and AIM-9 Sidewinder or AIM-120 AMRAAM missiles under the wings. It also has a 20mm M61 Vulcan Gatling gun built into the right wing root for defense. The C and D models use conformal fuel tanks that fit close to the body around the engines, carrying extra fuel and reducing the need for mid-flight refueling. Though they create some drag, it's less than regular external tanks, and they can't be dropped during flight. However, in the 2010s, the U.S. Air Force faced a shrinking number of fighter jets in the 2020s due to budget cuts and a focus on counterterrorism after the 2001 attacks. The plan to buy 381 F-22s to replace older F-15s was reduced to just 187 by 2009. To maintain enough fighters, the USAF planned to upgrade 179 older F-15CD jets with new radar and electronic systems, extending their service life to the 2030s. However, by the mid-2010s, these jets were too old to keep, and delays in the F-35 program created a need for new fighters. Restarting F-22 production was too expensive, so the USAF worked with Boeing to develop the F-15AX, a modern version of the F-15, based on export models like the F-15QA for Qatar. The F-15X includes advanced radar, better flight controls, and the ability to carry more missiles, with plans to build up to 104 jets for the USAF. Despite the United States Air Force's plans to replace their older F-15s with the newer F-22 Raptor by the 2010s, they did not buy as many F-22s as they hoped. Because of this, they kept some older F-15s in use until 2026 and started using a new version called the F-15EX Eagle II. The F-15EX is better than the earlier variants in aspects including the AOSA radar, an infrared search and track system, and the EPO-DOES electronic warfare system, which were taken from previous F-15 upgrades. It also added features from the F-15QA, like a stronger structure that can last 20,000 hours, a new cockpit, improved flight controls, and the Amber system, which allows it to carry up to 22 air-to-air missiles. Although this aircraft isn't as stealthy as fifth-generation jets like the F-22 or F-35, it can still help with air superiority missions. It can defend the homeland and air bases, enforce no-fly zones in areas with weaker air defenses, and launch large standoff weapons to support stealth fighters. In July 2020, the U.S. Department of Defense ordered 8 F-15EX for $1.2 billion over 3 years. The aircraft had its first flight on February 2, 2021, and was officially named Eagle II on April 7 that same year. Just a month after its first flight, the Air Force received its first Eagle II. On July 16, Air Combat Command Chief General Kenneth Wilsbach announced that Boeing's aircraft had achieved initial operational capability with the U.S. Air Force. This milestone was reached a year later than expected because of production delays. A 1-year buffer was added for the initial operational capability, which will be completed the next month. That same year, the defense budget set aside $1.23 billion to buy 12 more F-15EX, bringing the total order to 20 with a plan for 144 jets. By May 2022, the U.S. Air Force reduced its planned order to 80 aircraft. The first F-15EXs won't have conformal fuel tanks, but the Air Force's 2024 budget proposes buying 24 more jets, bringing the total fleet to 104. What makes this aircraft special compared to the other earlier variants is that it offers faster speeds, longer range, and lower operating costs compared to earlier versions. It can reach speeds of Mach 2.9 thanks to its 2 General Electric F-110 GE-129 engines, each producing 29,500 pounds of thrust with afterburners. This speed is close to that of the legendary SR-71 Blackbird, making the Eagle II the fastest fighter jet in the world. It also has the longest air-to-air combat range of any fighter jet in the U.S. Air Force. The Eagle II is the first U.S. Air Force F-15 to have digital fly-by-wire controls and a glass cockpit with a touchscreen. It has fly-by-wire flight controls, APG-81V1 ASA radar, which gives it a longer range and better ability to track and attack multiple targets with precision. The jet uses an open mission systems design. This design makes the jet more flexible, allowing easy upgrades with new technology, ensuring it stays useful for years. OMS also boosts the fighter's ability to operate on its own when disconnected from the global cloud network and reconnect when needed. The aircraft also features upgraded sensors and digital cockpits with flat-screen technology, an advanced APG-82 electronic scanning radar, and the Eagle Passive Active Warning and Survivability System, which greatly enhance its survival capabilities compared to earlier models. The cockpit also includes a powerful new computer, a 19 by 4-inch HD touchscreen, and an additional screen in the back seat for a co-pilot. Though the jet is usually flown by a single pilot, the pilots in its cockpit will benefit from this aircraft's smart helmet system called the Joint Helmet Mounted Cueing System, which allows them to target enemies accurately without having to aggressively maneuver the aircraft. All information about the aircraft's status and weapon systems is displayed on the helmet-mounted display, reducing the pilot's workload but slightly limiting combat capabilities. Being propelled by 2 powerful engines, F-110 GE-129 engines, each providing 29,000 pounds of thrust, that type of power makes the aircraft faster, more agile, and responsive, reaching speeds of up to Mach 2.5. That's quicker than the Russian Su-57, a twin-engine stealth multi-role fighter aircraft that was developed by Sukhoi, which reaches a speed of Mach 2, and the American F-35, which goes up to Mach 1.6. This fighter is designed to be the most heavily armed in the world, which gives it an edge over other airfighters. With 12 attachment points for air-to-air missiles and 15 for air-to-ground missiles, this airfighter can carry up to 13 tons of weapons. It can hold 22 AIM-9X Sidewinder and AIM-120D AMRAAM missiles, which have a range of up to 180 kilometers. In comparison, the F-35 can carry only 4 missiles internally. The Lockheed Martin F-35 Lightning II is an American fighter jet with 1 seat and 1 engine. It's designed to be stealthy and can perform a variety of roles, including air combat and strike missions. It also has advanced features for electronic warfare and can gather intelligence, conduct surveillance, and do reconnaissance. The idea is for the F-35 and F-15EX to work together in combat. The F-35 would stealthily find enemy targets, and the F-15X would strike with its powerful weapons. The F-15EX also has a longer service life, with 20,000 flight hours compared to the F-35's 8,000 hours. Together, these air fighters would be a combined force to reckon with. Although the F-15EX costs $87.7 million each, close to the F-35's price of $78 to $79 million, it is cheaper to operate, costing between $27,000 and $29,000 per flight hour, compared to the F-35's $38,000. Lockheed Martin plans to reduce the F-35's cost per hour to $25,000 by 2025, but the F-15EX's cost may also drop, keeping it budget-friendly. Besides this, the newest F-15 has the latest Suite 9.1 software, in common with upgraded legacy aircraft. Due to insufficient F-22 procurement, the F-15C fleet has continued flying beyond its design service life, posing a serious risk of structural failure. The jet's suite of powerful new systems and weaponry makes the F-15X one of the most advanced aircraft flying today, with more survivability than fifth-generation platforms such as the F-35. Speaking of Russia and China, both superpowers are terrified of the F-15EX because it was designed to counter China's J-20 fighter and Russia's Su-57 stealth aircraft. The Chengdu J-20, also known as the Mighty Dragon or NATO's Fagin, is a Chinese stealth fighter jet developed by Chengdu Aerospace Corporation for the People's Liberation Army Air Force. It is a fifth-generation aircraft designed to dominate the skies and perform precise strikes. On the other hand, the Sukhoi Su-57, also known as the Felon by NATO, is a Russian fighter jet with 2 engines and stealth features. It was developed by Sukhoi as part of the PAC-FA program, which started in 1999 to create a modern and cost-effective alternative to an older project. The Su-57 is the first Russian military aircraft built with stealth technology and aims to be the basis for a new generation of stealth fighters. It can perform various roles, including air combat and attacks on ground and sea targets, and it includes features like stealth, excellent maneuverability, high speed, and advanced electronics with a large payload capacity. The Sukhoi Su-57 was designed as a more versatile and capable stealth fighter compared to the Lockheed Martin F-22. Sukhoi addressed several limitations of the F-22, such as its inability to use thrust vectoring for roll and yaw, limited weapon space, and issues with stall recovery. Designed as a multi-role fighter, it has large internal weapon bays for carrying various ordnance without affecting stealth. Its advanced flight control system and maneuverability allow it to perform high-angle maneuvers and supercruise at Mach 1.3. With a range of over 1,500 and the option for aerial refueling, it has significantly better performance compared to older aircraft. There's no doubt that the Su-57 might be more sophisticated than the F-22. However, facing or defeating the combined force of the Eagle II and the F-35 Lightning would be impossible. The ultimate weapon, the legendary A-10 Warthog, is ready to take on modern ground threats head-on, with advanced upgrades that make it a fierce contender even alongside modern jets like the F-35. Its remarkable firepower and durability have earned it the nickname Tank Killer. Designed to dominate the battlefield, it built on lessons from the Korean War and improved on the success of the Douglas A-1 Skyraider, making it more formidable than ever. So what new upgrades make the Warthog stronger, and will it continue to stay relevant in the future? Join us as we reveal how the newly upgraded 2025 A-10 Warthog shocked the world. In the 1960s, when the world was faced with the threat of a nuclear war, Pentagon leaders realized that attaining victory wouldn't only be dependent on the availability of nuclear weapons, but also on the ability to support ground troops effectively. However, after the Second World War, the development of attack planes slowed down, leaving the U.S. vulnerable during the Vietnam War. The primary attack aircraft then was the Douglas A-1 Skyraider from the Korean War. Unfortunately, it didn't have enough firepower for the thick jungles of Vietnam and was quite vulnerable to ground fire. Recognizing the challenge that they were faced with, the need to strengthen air support became a major priority for the U.S. Air Force. They needed a plane that could handle Soviet tanks and protect infantry by breaking through enemy defenses. In September 1996, General John P. McConnell, Chief of Staff of the U.S. Air Force, ordered the creation of a specialized close air support aircraft, and this led to the creation of the AX program, or Attack Experimental. During the hunt for the perfect aviation company to bestow this incredibly important task upon, 6 companies submitted designs. However, the United States Air Force preferred the Northrop's YA-9A and Fairchild Republic's YA-10A the best. After a process of intense testing, they chose the YA-10A. The United States Air Force later updated its requirements and requested a more detailed proposal for the new aircraft. They considered the possible threat from Soviet armored forces and the need to operate in all weather conditions. The latest specifications included a 30mm rotary cannon, a top speed of 460 miles per hour, a takeoff distance of 4,000 feet, the ability to carry up to 16,000 pounds of weapons, a flight range of 285 miles, and a price of around $1.4 million. This would be the first U.S. Air Force plane designed specifically for close air support. To boost its effectiveness, the Air Force also requested a cannon with a minimum firing rate of 4,000 rounds per minute. This led to the creation of the GAU-8 cannon, which can penetrate armored vehicles from over 1,300 yards away, firing 65 rounds per second with 80% accuracy. The project included 4 types of ammunition: practice rounds, semi-armor-piercing explosives, armor-piercing incendiaries, and high-explosive incendiaries. The A-10 is also equipped with a powerful gun known as the Avenger. It is one of the strongest aircraft weapons ever built, making the A-10 a fast and deadly force that is capable of destroying enemy tanks with ease. The A-10 was also tested with other weapons like the AGM-65 Maverick missile and AGR-20E precision system, adding to its effectiveness against armored targets. This aircraft is renowned for its great firepower, its 30mm cannon, titanium armor plates, and its ability to support ground forces in close combat, making it a valuable asset in larger, more intense battles. As global threats change, it makes sense for the Air Force to keep the A-10 in service. It's effective against targets like fuel convoys, and it can carry a wide range of bombs, including laser-guided and precise missiles. It also plays a key role in many combat situations, such as counterinsurgency and close support for ground troops. It's no surprise that this tough aircraft has been upgraded many times to stay relevant. Since it was introduced in 1976, the A-10 has had a long career, and it's obvious that it won't be retired until at least 2040. No other aircraft in the U.S. military can match its ability to provide close air support to ground troops. Looking at how the A-10 turned out, it's surprising that such a big and heavy plane can be so agile and effective. Its main design goals are to be tough and easy to maintain. The Warthog was built to operate from rough airstrips and deal with engine damage from debris. This explains why its 2 engines, the General Electric TF-34GE100, are placed high and behind the wings in front of the tail. These engines have a high bypass ratio, which means they produce less heat that could be detected by heat-seeking missiles. Their placement also helps keep them running while the plane is being serviced or loaded with new equipment. Despite the A-10's powerful features, Congress wanted to see if it should continue spending $4.2 billion on the aircraft or replace it with the F-35 Lightning II. To make this decision, the Air Force was asked to upgrade the A-10 and prove if the F-35 could really take its place. To come to a conclusion, the Air Force responded by giving the A-10 8 major upgrades. Upgrading A-10Cs, which started in 2005, was a big improvement for the Warthog. It added precision weapons, some digital screens in the cockpit, and a laser pointer. Suite 10, which will be ready in spring 2021, is the next step in making the A-10 more modern. One of the first improvements was the V-12 lightweight aerial recovery system, which boosted communication between A-10 pilots and ground teams, including pararescue teams and pilots whose planes had been shot down. This system allowed the A-10 to provide even close air support and help with combat search and rescue missions. To improve its chances of surviving in modern combat, the aircraft was also equipped with longer-range weapons. Since it isn't that fast enough to avoid enemy fire when spotted in hostile airspace, it used to be risky for the plane to get too close before firing. But with its new weapons, the A-10 could engage targets from farther away, showing off its agility in the air. They also use updated strategies to avoid threats and also be able to attack some targets from a distance with precise weapons. After dealing with these threats, they can then move on to their usual missions without a hitch. With night vision goggles, the A-10 can still dominate the battlefield at night and at medium or low altitudes. It can also target ships using the AGR-12 precision weapon system, which loads rockets 4 times faster than before, making it an even more deadly force thanks to the 8th upgrade. Major Kading emphasized that being able to stay safe in battle is not just about having the best equipment and software. It is also about using the most effective and lethal strategies. He also stated that what makes their organization unique is that they focus on all of these critical aspects. Suite 9, which was introduced in 2019, made it possible for JTACs to share their position digitally with the A-10's onboard computer. This helps prevent accidentally targeting friendly forces. It also allowed it to attack multiple targets at once with precision-guided weapons. Now, the pilot can drop 6 weapons with just one button press, which used to require a lot of work. This aircraft can now use different types of bombs, like the GBU-38 or GBU-31 JDAMs, and the aircraft will tell the pilot if they can hit their targets on one pass. Also, this Suite 9 also included improvements to the pilot's helmet, called HOBIT, or Hybrid Optical-Based Inertial Tracker. This new helmet tracks the pilot's head movements more accurately using special dots on the canopy. Its capabilities only got better, and the upgrades made it even scarier. The upgraded A-10C carries up to 16,000 pounds of mixed ammunition on 8 underwing and 3 ventral pylons. These include 500-pound Mark 82 bombs, 2,000-pound Mark 84 bombs, GBU-39 small-diameter bombs, laser and GPS-guided bombs, precision joint direct attack munition, incendiary cluster bombs, combined effect munitions, and mines. Let's not forget the rockets, such as the AGM-65 Maverick, unguided and laser-guided 2.75-inch missiles, and the AIM-9 Sidewinder. In addition to all this, the A-10 carries infrared countermeasure flares, electronic countermeasure chaff, jammer pods, and illumination flares. As part of the Suite 9 upgrade, the A-10 was equipped with a situational awareness pad that allowed joint terminal attack controllers to send their positions digitally. This improved the A-10's ability to know where allies and other things were on the battlefield. Before, pilots had to visually search for friendly forces, which could be hard when dust and debris made them difficult to see. With this new upgrade, the A-10 had a clearer view, reducing the chances of mistakes and making it easier to avoid accidentally targeting friendly forces during the chaos of battle. Now that it can better distinguish between enemies and allies, the A-10 has become even more dangerous for its enemies. It can engage up to 6 targets at once using precision-guided weapons with just one button press. The A-10 is equipped with powerful weapons, including 2,000-pound GBU-31 bombs and 500-pound GBU-38 explosives, making it extremely effective at causing destruction. The A-10's accuracy has also improved with new high-tech helmets called Hybrid Optical-Based Inertial Trackers, or HOBITs. These helmets have mounted sights that respond to the pilot's head movements, saving time and effort. With advanced displays like the BAE Systems Visionic Scorpion system, pilots get crucial targeting information, improving their accuracy and mission effectiveness. Suite 10 will let the pilot attack multiple targets with different weapons in one go. It will also fully integrate the AGR-30 APKW's rocket, which lets the A-10 hit targets from far away with better accuracy. Adding the GBU-30 V3 GEM bombs will give it more ways to use new bomb fuses, and the pilot will get better feedback on bomb accuracy. Pilots will also be able to share info about threats with other A-10s using a data link, which will help keep them safe. Suite 11 testing will start after Suite 10 is ready. The 40th Flight Test Squadron in Florida is testing it now. Suite 11 will focus on adding new equipment, like a better screen in the cockpit, integrating the GBU-39 small-diameter bomb, improving audio, making the GPS harder to jam, and upgrading the radio. These changes will make the A-10 more modern and better at using weapons. The process of upgrading the A-10 with new wings started in 2007 and finished in 2019. The new wings should last longer, unlike the previous one, without needing repairs, and will also keep the Warthog flying until at least 2030. There's also a plan to get more new wings for other Warthogs. While there's no plan to put new engines in them right now, the upgrades it's getting will keep it a better option for the Air Force for a long time. The A-10 can truly be called the Terminator of U.S. military aircraft. It's built to survive direct hits from armor-piercing and high-explosive shells up to 23 millimeters. It has a backup control system if the hydraulic system fails and is designed to return to base even with serious damage, like losing an engine, half a tail, or part of a wing. During the 2003 Iraq invasion, pilot Kim Campbell's A-10 was hit by enemy fire. Even with damage to one engine and its hydraulic system, the plane still made it back to base using manual controls. This incident proved that the aircraft is even as rugged and agile than they thought it was. Aside from its agility, almost all of the aircraft's major components are interchangeable and can be installed on either the left or right side of the Warthog, making it incredibly easy to maintain even in the harshest field conditions. The list of such ambidextrous parts includes engines, vertical stabilizers, main landing gear, and other components. When developing the A-10, the goal was clear: to build a flying tank to destroy enemy tanks. To achieve this, engineers used a 1,200-pound titanium alloy armor, 1.5 inches thick, to protect the pilot and cockpit. This was one of the first times such advanced metal was used in aircraft. But could a heavily armored aircraft still fly with a damaged fuel tank? Engineers took steps to minimize damage to the fuel system. All 4 fuel tanks were placed near the center of the aircraft, away from the edges. This setup means that the tanks would need to be hit through the thick armor of the aircraft first. The fuel lines can seal themselves if they are damaged, and check valves stop fuel from leaking into damaged tanks. The tanks also have polyurethane foam inside and outside to block debris and reduce fuel leakage if hit. Additionally, fire barriers and extinguishing systems protect the engines. Even if all 4 fuel tanks are severely damaged, there is still enough fuel in 2 special sumps to fly for 230 miles. Since its early production, the A-10 has gone through several tests to ensure it performs at its best. One of the first major tests in the late 1970s involved modifying one A-10 into a 2-seat version called the YA-10B to explore how well it could handle all weather and night operations. Recently, Lieutenant Christopher Earle, a test analyst with the 59th Test and Evaluation Squadron, said that testing has been ongoing since 2020. The plan is to keep testing different types of anti-armor weapons to see how well they perform against vehicles with special armor. Now that the concept has been proven successful, the Air Force is gathering more data to improve performance further. With these new upgrades and features, how does this prove that the tank killer is a machine ready for battle, especially with advanced threats? Looking back into its history from previous missions, the Warthog was clearly built to stand the test of time. Its airframe was designed for durability, with measures such as 1,200 pounds of titanium armor to protect the cockpit and aircraft systems, enabling it to absorb damage and continue flying. Capable of taking damage, as much as losing half a wing, half a tail, one engine, or one elevator, and still make a complete flight back home. Its ability to take off and land from relatively short runways also makes it a huge favorite in operations from airstrips close to the front lines, and its simple design enables maintenance with minimal facilities. Proving all of its well-laid features, the A-10 made a notable appearance in America's involvement against Iraq's invasion of Kuwait in Operation Desert Storm during the First Gulf War in 1991. The American A-10s alone accomplished incredible feats. They managed to obliterate over 900 Iraqi tanks, along with an astonishing 2,000 other combat vehicles and 1,200 artillery pieces. In addition to that, this war beast was also involved in various conflicts, including those in Grenada, the Balkans, Afghanistan, Iraq, and against the Islamic State in the Middle East. Right now, the 422 Squadron is working on different tactics to improve how the Warthog performs in combat. One of these is about flying at night at lower altitudes and using better night vision technology. They're also looking into new ways to rescue people in dangerous situations and how to attack enemy ships using special rockets. They are attempting to make the airfighter get better at flying from places with limited support. All of these changes will make it more ready and effective in missions. The AGR-20 APKWS-2 rocket is a smart version of the old 2.75-inch rocket, which the A-10 started using in 2013. With its supreme capabilities, the Warthog has remained a favorite choice in modern warfare scenarios. Especially with its recent upgrades, it is even more effective in swiftly completing its mission objectives, no matter how challenging the terrain. Its abilities have only increased over time, making it an essential tool for any air squadron. These factors are the major reasons why the retirement of the A-10 has ever been delayed. The A-10's main technical strengths and combat abilities are being kept and improved, according to officials. In 2021, the A-10 performed well in a bombing campaign against ISIS, and the Air Force delayed its planned retirement. Instead, they began developing a new long-term version of the A-10. Earlier that year, Pentagon leaders announced that the A-10 would not retire and would stay in service until at least 2022. Now, both the Air Force and the Department of Defense want to keep the A-10 flying for many more years. It has been used by the U.S. Air Force in many missions, including in Afghanistan, Iraq, and other conflicts. After Russia invaded Ukraine in 2022, some U.S. officials suggested that A-10s could help Ukraine fight against Russian tanks, but talks have since shifted toward providing F-16 fighters. The future of the A-10 is still uncertain. The U.S. Air Force originally planned to keep it in service until 2028, then replace it with F-35 fighters. But many experts argued against this, pointing out how effective the A-10 still is and how expensive the F-35 is. Now, the A-10 might not be retired until the 2030s, so we may see it flying for years to come. In the changing world of air combat, the A-10 shows how important it is to be adaptable and resilient. Its unique design, with the GAU-8 Avenger cannon, titanium armor, and powerful weapons, has made it a crucial tool in close air support missions. From the roar of its cannon to the precision of its bombs, the A-10 has earned its place in military history. Elon Musk just made a jaw-dropping revelation in a stunning move that has sent shockwaves through the world of aviation. SpaceX, in collaboration with the U.S. Air Force, has just revealed a $4 billion aircraft that promises to revolutionize the skies. Equipped with advanced technology and capabilities unlike anything ever witnessed, this groundbreaking aircraft is set to redefine the future of air superiority. What are the capabilities of this new jet? What are the similarities between Elon's new aircraft and the United States' sixth-generation aircraft? Join us as we unveil the $4 billion sixth-generation aircraft Elon Musk just revealed to the world. SpaceX has quietly bought a new airplane, a Boeing 737-800, and painted it in a striking gray and black design. It's not clear what the company plans to do with this aircraft, but it could be used as a corporate shuttle, a testing platform, or both. The unique paint job and possible use have led to comparisons with some of the most secretive 737s in the world. Boeing started working on the narrow-body 737 in the early 1960s. They wanted to build a plane that could be used alongside the Boeing 727. The 737 was meant for shorter trips, while the 727 handled longer routes. But the 737 became very popular in the airline industry and eventually replaced the 727. Production of the 737 began in 1986, after Lufthansa received the first plane. Since then, about 12 Boeing 737s have been made, And Boeing is still making the latest version, the 737 MAX. There are also almost 5,000 more 737s on order. SpaceX uses a Boeing 737-800, which is part of the 737 Next Generation series. This series was introduced in 1993 to replace older 737 models. The 737-800 has a better wing design, which lets it carry more fuel and handle a higher maximum takeoff weight. This formidable aircraft is powered by CFM International CFM56-7 engines that provide over 27,000 pounds of thrust. Boeing also improved the aircraft's avionics and added new interior options. Here are the 737-800's specifications. The Boeing 737-800 has a maximum capacity of 189 passengers, with a length of 129 feet 6 inches, a height of 41 feet 2 inches, and a wingspan of 112 feet 7 inches. It has a maximum takeoff weight of 174,200 pounds, a cruise speed of 455 knots, and a range of 2,935 nautical miles. The aircraft's service ceiling is 41,000 feet. SpaceX's second plane is a Gulfstream G450. According to JetSpy, this plane was first built in 2007 and is registered as N450GG. The Federal Aviation Administration lists TVPX Aircraft Solutions, a trust for aircraft, as the registered owner. But JetSpy says that SpaceX is the one using the plane. According to JetSpy, in 2024, the Gulfstream G450 registered as N450GG has completed 150 flights, totaling flight hours. These flights consumed nearly 170,000 gallons of aviation fuel, resulting in 1,610 metric tons of carbon emissions. The top 3 airports visited by N450GG in 2024 are Draffen Miller Central Texas Regional Airport, Jack Northrop Field Hawthorne Municipal Airport, and Brownsville South Padre Island International Airport. This aircraft is an upgraded version of the Gulfstream 4, which was first developed in the early 1980s. The original Gulfstream 4 featured a stretched fuselage from the Gulfstream 3, along with new engines and other enhancements. Its first prototype flew in September 1985, and it was introduced in 1987. Introduced in 2004, there were further improved on the Gulfstream 4 with enhanced Rolls-Royce Tay 611-8C engines, providing nearly 14,000 pounds of thrust, a longer fuselage, the Honeywell Advanced Flight Deck Display Suite, better flight controls, and new landing gear. This aircraft has the capability to carry up to 19 passengers. It also measures 89 feet 4 inches in length, stands 25 feet 2 inches tall, and has a wingspan of 77 feet 10 inches. It has a maximum takeoff weight of 74,600 pounds, a maximum speed of 505 knots, a range of 4,350 nautical miles, and a service ceiling of 45,000 feet. What does Elon Musk's newly acquired aircraft have in common with the United States Next Generation Air Fighter, the NGAD, if any? The idea of a 6th-generation fighter jet marks the start of a new chapter in aerial warfare, featuring advanced abilities and the latest technologies. These upcoming aircraft are expected to change the game in air combat, offering better air-to-air fighting skills and the ability to enter heavily defended areas. Recently, several countries have revealed plans to develop their own 6th-generation fighter jets, highlighting a global effort to advance military aviation. The United States Air Force is a major player, working on the next-generation air dominance stealth fighter program. In 2013, DARPA Director Arati Prabhakar announced that the U.S. had started studying an air dominance initiative. This made aviation enthusiasts worldwide very excited, as the new aircraft was expected to feature the most powerful engines, advanced sensors, integrated artificial intelligence, and a swarm of drone wingmen. By 2016, the U.S. Air Force joined DARPA's research, launching the Air Superiority 2030 Plan. The Next Generation Air Dominance Program is an advanced project by the U.S. Air Force to develop a new fleet of highly advanced aircraft. The main focus is on creating a manned fighter jet called the Penetrating Counter-Air Platform, which is designed to break through heavily defended airspaces and tackle the toughest enemy threats. What makes the NGAD program even more exciting is that these manned jets will be supported by unmanned combat aircraft, known as loyal wingman platforms. These unmanned aircraft will fly alongside the PCA, taking on tasks like surveillance, electronic warfare, and direct combat, all while being controlled by the human pilot in the PCA. This combination of manned and unmanned systems will create a powerful and flexible force that can adapt to various combat situations. The NGAD program isn't just about creating a better fighter jet, it's about transforming air combat entirely. By using advanced technologies like artificial intelligence, cutting-edge sensors, and new propulsion systems, the NGAD aircraft will be able to perform more effectively in the tough, contested airspace of the future. These innovations will give the United States unmatched control of the skies, ensuring air superiority for many years to come. One of the standout features of the NGAD program is its focus on flexibility and quick upgrades. Unlike older aircraft that took a long time to develop and were hard to upgrade, NGAD is designed to quickly incorporate new technologies as they emerge. This means the NGAD aircraft will stay at the forefront of military aviation, ready to counter any new threats from adversaries. The idea for this program started when the Defense Advanced Research Projects Agency explored concepts for future air superiority systems for the U.S. Air Force and Navy, targeting the 2030s. After completing their Air Dominance Initiative study in March 2015, DARPA's findings led to the launch of the Aerospace Innovation Initiative in 2015. This initiative aimed to develop prototype X-planes to showcase next-generation fighter technologies. The NGAD program is also changing how the Air Force acquires new aircraft. They are separating the design, building, and maintenance tasks and have allocated $9 billion to achieve this by 2025. The plan includes holding more competitions and frequently testing the designs to ensure they are effective. Although this project started with the idea of creating one type of plane, they are now planning to develop a group of different systems. At the core of this group is a manned fighter plane, supported by drones and computer systems to enhance its performance. The goal is to create a system that performs well in the Indo-Pacific region, where current Air Force planes lack sufficient range and power. They might even develop two versions, one for the Indo-Pacific and another for closer battle areas like Europe. When the American sixth-generation fighter was just entering the concept stage, DARPA considered combining the expertise of specialists from the U.S. Air Force and Navy. However, it was soon recommended that these branches develop their fighters independently. Rumor has it that DARPA aimed to foster friendly competition between the services, hoping to get two excellent new generation fighters instead of one. Consequently, the Air Force focused on developing the NGAD, while the Navy embarked on its own FXX program. Despite various hypersonic and missile programs, stealth remains crucial for the future success of the U.S. Air Force. Making the sixth generation even stealthier might be challenging, given the near invisibility of the Raptor on enemy radars, and the even more advanced stealth of the F-35 Lightning II. The F-22 boasts some of the most impressive stealth features, with a radar cross-section of 0.01 square meters, appearing like a small marble on enemy radar. However, its high cost of $350 million is a drawback. Therefore, NGAD specialists aim to equip the sixth generation with advanced technology while managing costs to avoid burdening taxpayers. From fiscal years 2024 to 2027, the U.S. Air Force's estimated additional cost for the NGAD program will exceed $1.7 billion. Each futuristic fighter is expected to cost several $100 million, according to Secretary of the Air Force Frank Kendall. For now, let's set aside the financial concerns and look forward to the potential future characteristics of this advanced aircraft. The new fighter plane is expected to feature advanced engines that would be ready by 2025. Initially, they aimed to produce these new fighters quickly, similar to the process used in the 1950s, but they have now adopted a more traditional approach. The plan is to start using these new fighters in the 2030s once they have enough of them. Some new technologies are being tested on existing planes like the F-22. Modern fighter engines perform optimally at a specific point in the flight envelope. To enhance efficiency at any speed and altitude, sixth-generation fighters may incorporate a variable cycle engine. This design promises better range, faster acceleration, and improve subsonic cruise efficiency. The engines will function as turbojets at supersonic speeds and as high bypass turbofans at lower speeds. Teams from General Electric with their XA100 engine and Pratt & Whitney with their XA101 are responsible for this capability, working under the U.S. Air Force's Adaptive Engine Transition Program. They aim to integrate these engines not only into NGAD fighters, but also into the existing F-35 fleet. For instance, the Raptor is renowned for its supercruise capability, a core requirement of the Advanced Tactical Fighter program that led to its development. However, supercruise consumes a lot of fuel, so it is often limited to short tactical bursts during missions. If supercruise could be sustained for longer periods without excessive fuel consumption, it would greatly reduce travel time to and from mission areas. This presents a significant challenge for the team developing NGAD. The design of the new fighter will likely deviate from traditional norms, featuring a highly streamlined shape with an elongated mixed fuselage and wings without traditional horizontal and vertical stabilizers. This tailless configuration will prioritize low observability across a broad radio frequency range to enhance survivability, while also improving aerodynamic efficiency. The fuselage materials will likely include advanced stealth coatings to conceal the aircraft from infrared detection and minimize heat emission. Combined with advanced thermal management systems, engineers must ensure that these stealth coatings remain intact and do not require extensive maintenance after each flight, even at high speeds. Another crucial consideration for the NGAD team will be the operating altitude of their next-generation fighter. The F-22, for instance, can fly at over 60,000 feet, nearing the point where pilots would need full pressure suits. Missiles launched from such heights can travel much farther than those fired from 20,000 feet below. Given the threat environment NGAD will face, which includes space and spectrum warfare, it becomes clear: the higher the altitude, the more versatile the aircraft. Higher altitudes also provide a significant line of sight advantage for the fighter's sensors and communication systems. At 40,000 feet, the line of sight is about 245 miles, but at 60,000 feet, it exceeds 300 miles. This extended range is a strategic asset, especially when navigating through dense enemy air defense networks. Operating at such heights not only enhances missile performance, but also maximizes the aircraft's overall situational awareness and effectiveness in combat scenarios. Like every other advanced air fighter, the NGAD fighters need constant data exchange with collaborative combat aircraft and other U.S. Air Force and Navy planes. Acting as both a quarterback and a heavy hitter, the NGAD's communication range is vital. Every extra mile of connectivity enhances the fighter's survivability and expands its operational area without relying on beyond line-of-sight repeaters like satellites. Now to one of the most important parts, the armaments. The NGAD might be equipped with more than just the standard missiles used by the F-22 and F-35. It will also feature the cutting-edge A-26A Joint Advanced Tactical Missile that is currently being developed by Lockheed Martin. Additionally, it will have long-range engagement weapons, which Raytheon is developing alongside its air-to-air missiles. For over a decade, senior Pentagon officials have praised air-breathing hypersonic systems as the weapons of the future, making them a likely addition to the NGAD's arsenal. And then there are the weaponized lasers. The U.S. Air Force is already testing lasers with 100 to 150 kilowatts of focus power as part of Lockheed Martin's Laser Advancements for Next-Generation Compact Environments program and the Self-Protect High-Energy Laser Demonstrator, a joint effort by Northrop Grumman, Boeing, and Lockheed. Using these lasers to protect NGAD fighters from incoming enemy missiles by blinding or frying their homing systems is very possible. In June 2022, the U.S. Air Force determined that key technologies were ready to support the next phase of the program, called Engineering and Manufacturing Development. They had tested a full-scale prototype of the NGAD fighter plane in 2020 as part of the AII X-plane program and tested 3 different prototypes by 2023. They officially requested proposals in May 2023, with plans to select a company to collaborate with by 2024. A Chinese state-backed newspaper recently revealed a tailless design for its developing 6th-generation aircraft, which looks very similar to U.S. 6th-generation fighter jet concepts. While the exact design of the U.S. 6th-generation fighter hasn't been made public, The Chinese design closely matches concepts shown by U.S. weapons manufacturers a few years ago. The Chinese newspaper, Global Times, pointed to a video from the Aviation Industry Corporation of China where this design was featured. The newspaper describes the tailless, finless aircraft as having a blended wing body design, which offers better lift, longer range, and lower fuel consumption. However, its most important feature is its stealth ability. Vertical parts like tails and fins improve speed and maneuverability, but make the aircraft more visible to radar. Protruding parts like fins, tails, and external weapons can be detected by enemy radar because they reflect electromagnetic signals. Sharp edges and tails are easier for radar to spot compared to smooth aircraft, like the B-2 bomber. This is why stealth fighters like the F-35 carry weapons internally, keeping the exterior smooth to reduce radar detection. Even with its stealthy and aerodynamic design, the new Chinese aircraft appears to resemble U.S. designs from several years ago. This similarity isn't surprising, given concerns about China's attempts to copy U.S. weapon specs through cyber espionage. It's not unexpected that the technical plans and systems for China's sixth-generation technology, as described by the Global Times in 2020, closely resemble those of the F-35. According to the Chinese newspaper, the new PLA Air Force sixth-generation aircraft will feature an autonomous computerized system to gather, organize, and present various information sources to pilots. J-20 designer Yang Wei was quoted in the 2020 Global Times article, saying that a future fighter jet will need longer range, better endurance, stronger stealth, a larger load of air-to-air and air-to-surface weapons, and the ability to provide pilots with easy-to-understand battlefield information and predictions. This focus on giving pilots clear and simple warzone intelligence is very similar to the F-35's sensor fusion. In an F-35, data from 360-degree cameras, long-range targeting, navigation, threat warnings, and other factors like speed, altitude, and angle of approach are combined, analyzed, integrated, and shown on a single screen for the pilot. China's vision for its new generation fighters closely mirrors that of the US. The paper explains that in an integrated system, the aircraft should connect to a network, generate real-time situational images, create multiple attack routes, and share target information across mission areas in real time. Artificial intelligence is crucial in the early design and testing of US sixth-generation stealth fighters. AI will likely integrate more data sources, such as electronic warfare, space, radar warning signals, and unknown indicators into the aircraft's systems. Advanced algorithms can quickly analyze large amounts of incoming data, compare it with a vast database, and make near real-time decisions and calculations. This helps pilots make faster and clearer decisions, reducing their mental workload. These are the main goals of AI-driven programs, which is why they are a focus for the new generation of Chinese stealth fighters. Technologies like conformal sensors built into the aircraft's body, known as smart skins, are examples of innovations likely to be used in sixth-generation fighters. Other features mentioned in the Chinese report include new stealth designs, advanced weapons like lasers, adaptive engines, and the ability to control drones. While much attention has been given to the stealthy exterior of China's fifth-generation aircraft, which resembles an F-35, less is known about the internal technology of advanced Chinese fighters. The real difference in what makes a fifth or sixth-generation aircraft superior might come down to AI's role in computing, sensing, targeting, maneuvering, and various combat strategies. The world is advancing, and so are the dynamics of modern warfare. From stones and wooden clubs to advanced weaponry, technology has continuously redefined the battlefield. Recently, the United States unveiled a revolutionary hypersonic laser, a weapon that has captured global attention and sparked concern among adversaries. But what makes this hypersonic laser so formidable? How have other nations reacted to this new development? Join us as we unveil the shocking capabilities of the US's new hypersonic laser that has defied the laws of physics. After American engineer and physicist Theodore Maiman created the laser in 1960, it quickly became the go-to weapon for both science fiction authors and military strategists. This wasn't surprising. Though Maimon initially highlighted the scientific possibilities of his invention, the public immediately linked the laser to the heat ray from H.G. Wells' War of the Worlds. Headlines at the time even called it a science fiction death ray, like one in the Los Angeles Herald, as noted in Jeff Hecht's book, Beam, The Race to Make the Laser. However, Maimon himself saw it differently, thinking of the laser more as a life ray due to its potential medical uses. Laser systems were first used by the U.S. military during the Vietnam War to help guide laser-targeted bombs. However, the use of lasers has only gotten better since then. They have been used to measure distance to a target, signal and communicate, and disrupt enemy optical devices. They have also been used to scare enemies. U.S. troops can frighten bad guys by pointing visible laser-aimed spots on their chests at night. However, lasers have advanced significantly, and the United States is making sure of that. This system is not just tools to support other weapons or non-lethal systems. Lasers themselves will become powerful weapons. Megawatt-class lasers will be deployed on the ground, in the air, and even in space, acting as ultra-fast defense systems. Colonel Michael W. Bowen, who directs the Air Force's Airborne Laser Program, stated that it's hard to fully grasp what lasers as weapons will mean, especially given their speed. Unlike airplanes or missiles, which we understand, the speed of light is much harder to comprehend. The Pentagon, however, wasted no time in exploring how lasers could be used in the military, from practical applications like guiding bombs to ambitious projects like the 1980s Strategic Defense Initiative, known as Star Wars. Yet it's only in recent years that the technology has advanced enough to make laser weapons truly effective against their targets. In the mid-2000s, the Air Force used its Boeing 747-based YAL-1 airborne laser to successfully shoot down ballistic missiles during tests. At the same time, the Army's Humvee-mounted Zeus HHMWV laser ordnance neutralization system was deployed in Afghanistan and Iraq to destroy landmines, IEDs, and unexploded bombs. By 2014, the Navy's AN/SEQ-3 laser weapon system was effectively disabling drones and small boats from the USS Ponce, making it the world's first active laser weapon. When the USS Ponce was decommissioned in 2017, a more advanced laser system was installed on the USS Portland, which successfully tested it in 2020 and 2021. The Pentagon has mostly focused on using modern laser weapons for defensive purposes. According to a 2023 report, high-energy lasers could be very effective in short-range air defense, taking out helicopters, low-flying aircraft, and incoming rockets, artillery, and mortars. With enough power, these lasers could even destroy cruise and ballistic missiles. After years of progress, the U.S. military is finally bringing laser weapons into actual use. The Pentagon has been investing about $1 billion a year in over 30 laser programs since 2020 and has deployed several of these weapons for testing abroad. Some of these include the Air Force's high-energy laser weapon system, which was tested overseas in 2021, the Marine Corps' compact laser weapon system, which Marines have been training with in the Middle East since 2021, Lockheed Martin's Helios system, currently on the USS Preble, and the Army's 50-kilowatt laser system mounted on a Stryker vehicle known as Guardian, which was sent to the Middle East for testing in February. The Army also received a 300-kilowatt Valkyrie laser to defend against cruise missiles. Blue Halo's Locust laser weapon system, used in the P-HEL, is likely just the beginning. In 2023, the company received contracts to develop new laser systems for the Army's next-generation infantry squad vehicle and a potential system for the Marine Corps' new tactical vehicles that will replace the aging Humvee fleet. Laser weapons are no longer just theoretical. They are becoming real hardware. The airborne laser is the closest to being a working, hard-kill laser weapon for the U.S. military. The Air Force sees it as a top priority, just after the F-22 fighter. The ABL's mission will be to patrol the skies near battle zones, using infrared sensors to detect the launch of enemy ballistic missiles. Once it spots a missile, the ABL, a modified 747 equipped with lasers for targeting and attack, will lock onto it. When the missile rises above the clouds, the ABL will focus a 15-inch wide laser beam on its surface. This will cause the missile's skin to heat up and rupture, leading to an explosion. The debris, including the missile warhead, will fall back onto the country that launched it. This is expected to deter the use of such missiles in the first place. The airborne laser system is designed to detect and destroy enemy missiles from the air. It locates missile launch sites and can guide attack aircraft to destroy other missiles before they can be fired. The system uses a powerful laser to heat and destroy a missile's surface from hundreds of miles away. Two main challenges were developing a strong enough laser and keeping the beam focused despite atmospheric disturbances. But these problems have been solved. The laser is powered by a chemical reaction similar to mixing household bleach and drain cleaner. To create a powerful beam, the laser is then focused using adaptive optics, which adjusts the beam to stay accurate despite atmospheric conditions. However, creating a system light and durable enough for regular use remains a challenge. The ABL, which could shoot down around 20 missiles per mission, is considered the first generation of laser weapons. Future advancements may lead to even more powerful and versatile lasers, potentially used on smaller aircraft or even from space. The ABL is paving the way for these future technologies. The U.S. Navy's Office of Naval Research has stated that they have also been leading the effort on directed energy weapons. These systems, as they explained, are electromagnetic systems that can convert chemical or electrical energy into radiated energy, which is then focused on a target. This focus causes physical damage that can degrade, neutralize, defeat, or destroy an adversary's capability. The Navy's DEWs include high-energy lasers, which emit photons, and high-power microwaves, which release radio frequency waves. The Navy could potentially use these DEWs for power projection and integrated defense missions. The Office of Naval Research further explained that high-power microwaves, a type of DEO, could produce beams of electromagnetic energy across a broad spectrum of radio and microwave frequencies. These beams could be either narrowband or wideband, with the goal of interacting with the electronics in targeted systems, either causing damage or temporary disruption that prevents the system from recovering in time to complete its mission. HPM have several important advantages, such as attacking at the speed of light, having a large supply of power, and requiring only a moderate amount of electrical power from the platform they're on. They also use wide beams to cover large areas, making targeting easier. These weapons could be useful in crowded urban areas where traditional weapons might be limited. However, these systems wouldn't replace more advanced surface-to-air missiles, but would add another layer of defense. According to the War Zone, this would allow air defense missiles to be saved for more significant threats like anti-ship ballistic missiles, while drones and other smaller threats could be handled by the HPM DEWs. As technology gets better, high-power microwaves might be able to use microwave energy to damage the electronics of targets, making them useful for stopping anti-ship ballistic missiles like those used by China's People's Liberation Army rocket force. The U.S. Navy hasn't shared which defense companies are involved in the Meteor program or similar projects. However, in December, Raytheon announced that it would design, build, and test two high-power microwave antenna systems to use directed energy to counter airborne threats at the speed of light. Raytheon stated that these systems would be tough and easy to transport for use on the front lines. Raytheon will provide these prototype systems to the U.S. Navy and U.S. Air Force over 3 years under a $31.3 million contract from the Naval Surface Warfare Center Dahlgren Division. This is part of the Directed Energy Frontline Electromagnetic Neutralization and Defeat program. Stating that the U.S. is advancing in terms of military technology is not an understatement. This country has also sent 2 high-energy laser weapons overseas to protect American troops and allies from enemy drones. This is the first time such a laser system has been used for air defense in military history. According to a top official, these weapons are already shooting down threats. The laser weapon, called the Palletized High-Energy Laser, was created by the defense company Blue Halo. It is based on their 20-kilowatt Locust laser weapon system. The first PHEL was sent to an undisclosed location overseas and started operations in November 2022, while a second one arrived earlier this year. At first, the Army didn't say where the systems were sent or if they had successfully destroyed an enemy drone due to security reasons. However, a top official recently confirmed that the laser weapons had successfully taken down threats in the Middle East. The Helios, or high-energy laser with integrated optical dazzler and surveillance system, developed by Lockheed Martin, is an advanced directed energy weapon that has been integrated into the U.S. Navy's Arleigh Burke-class destroyers. The first Helios system was delivered to the Navy and installed on the USS Preble in 2022. This system is part of the broader Surface Navy Laser Weapon System program, which aims to enhance the Navy's capabilities with advanced laser weapons. It is a versatile system with multiple roles. It can act as a powerful laser weapon capable of damaging or destroying small targets such as drones and small boats. Additionally, it functions as an optical dazzler, designed to confuse or blind enemy sensors, which can be critical in disrupting enemy surveillance and targeting systems. The system is also integrated with the Aegis combat system, enabling coordinated defense measures against various threats. The development and deployment of Helios mark a significant step in the Navy's efforts to incorporate more advanced, cost-effective, and scalable directed energy weapons into its fleet. The system is expected to undergo further testing and operational integration with potential upgrades, including increasing the laser's power to 150 kilowatts. The United States Navy is currently working on high-powered microwave technology, but it's not for cooking food. Instead, this technology is being developed to protect sailors from airborne threats. The Navy plans to install a high-powered microwave system on a ship as early as 2026. According to the Navy's fiscal year 2026 budget request, this system is part of Project Meteor, which is focused on creating a directed energy weapon prototype. The Meteor system is expected to offer a low cost per shot, a large number of shots, significant range, quick engagement with multiple targets, and the ability to both deceive and defeat threats. The U.S. military isn't the only one working on adding laser weapons to its air defenses. The Dragonfire laser weapon was first shown publicly at the 2017 DSEI conference in London. It was developed through a partnership between the British Ministry of Defence and private companies including MBDA UK, Cinetti Q, Leonardo, GKN, Arca, BAE Systems, and Marshall Land Systems, with contracts totaling 100 million euros. Initial trials were planned for 2018, but delays due to the COVID-19 pandemic and technical issues pushed testing to 2022 in Scotland's Outer Hebrides. Early low-power trials proved the weapon's ability to accurately track air and sea targets. In November 2022, high-power tests showed that Dragonfire could effectively engage targets using its laser in realistic scenarios. By January 2024, it successfully engaged an airborne target in Scotland, with the MOD stating its precision is so high that it could hit a €1 coin from a kilometer away. The Dragonfire has been tested against mortar rounds and drones and fitted to a Wolfhound armored vehicle. The MOD also highlighted the low cost per shot, only €10 for 10 seconds of firing. In April 2024, the MOD announced faster development due to new procurement rules, aiming to have Dragonfire on Royal Navy ships by 2027, earlier than the originally planned 2032. UK Defense Secretary Grant Shapps mentioned that an early version of the weapon could be sent to Ukraine for use against Russia in the ongoing conflict. The Dragonfire uses UK-developed beam-combining technology to create a more powerful laser with greater range and faster target defeat times. The laser, which is around 50 kilowatts, is designed to protect land and sea targets from threats like missiles and mortar rounds. It includes a targeting system with an electro-optical camera and a second lower-power laser for tracking. The exact range of the weapon is classified, but it is expected to be used on future Royal Navy warships, British Army armored vehicles, and Royal Air Force fighter aircraft, such as the BAE Systems Tempest. The MOD plans to demonstrate the technology on a Type 23 frigate and a Wolfhound armored vehicle. In April, the UK Royal Navy announced it would speed up the installation of its new 50-kilowatt Dragonfire laser on a warship by 2027, 5 years earlier than planned, because of the growing need to counter drone and missile threats like those from Houthi rebels. Just a week later, U.S. House Republicans revealed a security assistance package for Israel, including $1.2 billion to help develop Israel's Iron Beam laser system to defend against short-range rocket attacks from Hamas militants. Other countries like Russia, China, France, India, and Turkey have also been heavily investing in laser systems in recent years, according to the RAND Corporation. The Peresvet, named after Alexander Peresvet, is a Russian laser weapon designed for air defense and anti-satellite warfare. It is one of the 6 new strategic weapons unveiled by Russian President Vladimir Putin on March 1, 2018. As of May 2022, 5 units of the system are reportedly in active service. The Peresvet system was first introduced by President Putin during his address to the Federal Assembly on March 1, 2018. The deployment of these systems within the Russian armed forces began in 2017, and on December 1, 2018, the Peresvet laser complex entered experimental combat duty. Putin stated that these laser complexes were expected to be fully operational by December 2019. The Peresvet systems have been deployed alongside road-mobile ICBM launchers, with the primary mission of protecting their maneuvers. On December 1, 2019, Russian Defense Minister Sergei Shoigu announced that Peresvet had been deployed with 5 divisions of the Strategic Missile Forces. Military expert Igor Korochenko, director of the Center for Analysis of the World Trade in Arms, has stated that the Peresvet combat laser is effective against unmanned aerial vehicles. However, its performance is heavily influenced by environmental conditions. While it works well in clear weather, factors like fog, rain, and snow can disrupt the laser beam. Korochenko also noted that the system consumes a large amount of electricity, making it impractical as a portable tool. Instead, it could be used to protect military bases and other strategic locations from UAV intrusions. In May 2022, during the Russian invasion of Ukraine, Russian Deputy Prime Minister Yuri Borisov claimed that a more advanced version of the Peresvet, called Zadira, was being used by Russian forces in Ukraine. Borisov claimed that Zadira can incinerate targets up to 3 miles away within 5 seconds. Chinese scientists, on the other hand, claim they have developed a laser weapon that can fire indefinitely, which would make it much more effective than other laser weapons. Around the world, armies are testing high-energy laser weapons to hit targets quickly. If successful, these weapons could revolutionize warfare because they move at almost the speed of light. China says it has found a way to reduce the cooling time, allowing such a weapon to keep firing without stopping. China's military researchers at the National University of Defense Technology in Hunan say they created a cooling system that lets high-energy lasers keep working without overheating. This was reported by the South China Morning Post. According to the scientists, this system is a major breakthrough in improving the performance of high-energy laser systems. They explain that their system can maintain high-quality laser beams continuously, not just for the first second. Laser beams can heat up the air, which can reduce their quality and damage the laser. To solve this, the scientists developed a system that blows clean gas through the laser chamber, removing waste heat. This also made the laser smaller and more efficient. This is the first time China has made public some of its advanced designs and research on managing the heat in these laser systems. Countries like China and the US are trying to develop powerful laser weapons for combat that can generate beams strong enough to melt steel. These laser weapons could be a game changer in warfare because they can hit targets like drones and missiles almost instantly and at a lower cost than traditional missiles. However, cooling the lasers has been a challenge. Steve Weaver, a former British military official, said that if China's claims are true, it would put China ahead of the US in developing these high-energy laser weapons, which the US has struggled with. While laser weapons show promise, they have limitations. Their power decreases over distance, and bad weather like fog and storms can reduce their effectiveness. Cooling the lasers is also a major challenge. As the threat of war intensifies, the United States, a nation at the forefront of technological advancement, is preparing to enhance its defense capabilities both in the air and at sea. This country has secretly tested its news, an extremely dangerous laser system, on one of its most formidable aircraft carriers, transforming the sea behemoth into a highly effective war machine. What makes this laser system exceptional? How does it transform the aircraft carrier into a formidable force on the battlefield? Join us as we explore the mind-blowing capabilities of the US's recent war beast. After years of research, the US Navy is finally nearing a cost-effective solution to defend against threats at sea from drone swarms and anti-ship missiles that have been increasing these past few years. In the third quarter of fiscal year 2022, the Navy received its first Helios system from Lockheed Martin. This high-energy laser is capable of directing over 60 kilowatts of energy at targets up to 5 miles away. It is being installed on a Flight 2A Arleigh Burke-class destroyer that is currently being upgraded. Laying emphasis on the importance of its production, Rick Cordero from Lockheed Martin revealed that the Helios defense system stands to improve the ship's combat effectiveness, helping to deter future threats and protect sailors. It also provides a strong foundation for developing advanced laser weapon capabilities. According to Navy budget documents, Helios is part of the Navy's laser family of systems, which is planned to be the base for gradually increasing laser weapon capabilities. For the 2023 budget, the Navy requested around $35 million for this family of systems, with the first system expected to be in use at sea during this period. The system doesn't just help to improve defenses against surface threats, but also fill gaps in counterintelligence and surveillance. It can dazzle and destroy unmanned aerial systems and combat fast, small attack boats. While laser defense systems are cheaper and have unlimited ammunition, they can be affected by weather and can only target what is in their line of sight. Conventional weapons will still be needed for larger or longer-range threats. Regardless of limitations, this technology represents major improvements over current systems for dealing with drones and anti-ship missiles. According to a Congressional Research Service report from August, surface-to-air missiles and Gatling guns are not cost-effective for shooting down cheap drones and require extensive reloading, which involves traveling long distances to reach a safe zone. The report, Navy Shipboard Lasers, Background and Issues for Congress, laid emphasis on the fact that China has many UAVs and anti-ship missiles and is capable of producing even more. This could make it expensive for the Navy to defend itself effectively. Tristan Sauer, a land domain analyst at Global Data, highlighted the main concern as how to target, track, and neutralize potential swarms or saturation attacks by small, unmanned vessels like micro-UAVs or small surface vessels. As using drones alongside manned platforms becomes more practical, it is spreading across the battlefield, even in countries with limited resources. For this specific reason, laser weapon systems are useful here because they are very cheap per shot and have a large supply of ammunition. This would help to counter the aerial threats in a cheap way. The Russian invasion of Ukraine has shown how a shortage of munitions can be a major problem. Some defense companies have struggled to keep up with production while also dealing with supply chain issues from the COVID-19 pandemic. Sauer pointed out that laser weapons need very little energy to produce significant effects, making them crucial for maintaining operations, especially in intense conflicts. The earlier version of the solid-state laser system, known as AN/SEQ-3 laws, was installed temporarily on the USS Ponce. However, it had trouble targeting very small objects, like the smallest drones. Due to various operational issues, it was not produced in large quantities and was later replaced by the high-energy laser with integrated optical dazzler and surveillance. Despite its operational issues, the laser system showed its potential. What were the capabilities of LAWS defense system? Let's check out the features of the earliest prototype of close-range defense against small drones and boats. Designed to target drones and a Mach small boat, this defense system uses an infrared laser beam that can be adjusted to either destroy a target or just disable its sensors. One of its benefits is the low cost per shot, as it only needs energy to fire, unlike traditional weapons that require ammunition and take up space. LAWS is meant for dealing with less advanced threats. It can be set to low power to temporarily blind or distract a person without causing harm, or high power to damage sensors, burn out motors, or destroy explosives. It can shoot down a small drone in just 2 seconds and can quickly disable small boats by targeting their motors. It's designed to hit the platform rather than individual crew members, but it can also destroy rockets on board. For larger targets like helicopters, Laos can damage key parts to bring them down. In 2010, Kratos Defense and Security Solutions was given an $11 million contract to help the Naval Surface Warfare Center develop a laser weapon for the U.S. Navy. This system, called LOS, was tested in May 2010 by using a radar system to track a drone. As earlier mentioned, the LOS was installed on the USS Ponce in 2014 for a one-year trial. The Navy also spent about $40 million on developing and testing this weapon over 6 years. The LOS is guided by the Phalanx CIW's radar and has a range of about 1 mile. Its power is estimated to be between 15 and 50 kilowatts, enough to target small aircraft and fast boats. One of the reasons the Navy is interested in laser weapons is because they are cheaper to use, costing around $1 per shot, while traditional weapons like missiles can cost thousands. Lasers have been tested since the 1980s, but older versions were not suitable for ships. This defense system also uses 6 commercial welding lasers that focus on the target together. In tests, it produced 33 kilowatts, and future versions could generate 60 to 100 kilowatts, capable of destroying fast boats, drones, planes, and missiles within a few miles. LOS was envisioned as a short-range defense system, mainly against drones and boats. However, more powerful versions have been developed. In late August 2014, the LOS laser weapon was deployed on the USS Ponce in the Persian Gulf with the U.S. Fifth Fleet. Its purpose was to test how well it works in a marine environment with challenges like heat, humidity, dust, and salt water, and to measure its power usage. The LOS can adjust its power level to either fire a harmless beam to warn a suspicious vessel or a stronger beam to destroy a target. The weapon's range is classified. Although Iran has threatened to block the Strait of Hormuz with small boats, which the LOS can handle, the system wasn't specifically designed for use against any one country. In September 2014, the LOS was declared fully operational, allowing ship commanders to use it for self-defense. According to international rules, it can't target humans, but it can be used against drones, helicopters, and fast patrol boats. The Navy released videos showing LOS disabling a drone, exploding a grenade, and destroying the engine of a small boat. The system has exceeded expectations and is very cost-effective, with each laser shot costing only 59 cents compared to expensive missiles. The LOS uses commercial laser parts and special Navy software, powered by a diesel generator separate from the ship's main power system. This makes it highly efficient. It's mounted on the USS Ponce's superstructure and can also be used for surveillance, with sailors comparing its abilities to the Hubble Space Telescope. Sailors trained with it daily, using a simple flat screen and a controller similar to a video game, making it easy to operate. The system performed well in tough weather conditions like humidity and dust storms, though it wasn't tested in severe sandstorms, as threats would also be unlikely to function in those conditions. The Navy is considering deploying it on other ships, and due to its strong performance, the LOS stayed on the USS Ponce for as long as the ship remained at sea. After reviewing several ship types to see which had enough space, power, and cooling, the Navy decided that once the USS Ponce was decommissioned in 2018, the LOS was to be moved to the USS Portland for more testing. The system will use space and power connections meant for a missile launcher, with the laser mounted on the deck. Since it was just a trial, the LOS was not fully integrated into the ship's defense system. Unfortunately, the LOS didn't go into mass production because it had some issues as a prototype. These included bulky capacitors that charged slowly, trouble tracking small targets, and difficulty combining the 6 lasers into one strong, synchronized beam. These limitations were resolved by the Helios. In January 2018, the Navy signed a $150 million contract with Lockheed Martin to build 2 Helios units, with one planned for the USS Arleigh Burke and the other for land testing. 4 years later, the Helios system was delivered to the Navy. This defense system is deemed special because it is designed to fix some of the issues with earlier laser systems. Unlike older models that needed extra energy sources, Helios uses the ship's existing power for continuous operations, according to Lockheed Martin. This new system has significant advantages over previous lasers. For instance, the older LAWES system could only reach 30 kilowatts of power and wasn't meant for long-term use. The Helios system is being installed alongside an upgrade of the Aegis weapon system at the Navy's facility in San Diego. The Aegis system, which has been in use since the 1980s, is getting modernized by Lockheed Martin for destroyers and other ships. While the Aegis system is being upgraded, the Helios would be integrated into both the ship and the Aegis system, making it a permanent fixture. It uses advanced spectral beam combined fiber lasers, which offer better beam quality compared to LAWES's older laser setup. Moreover, Helios can dazzle drones as well as destroy them, providing a major boost to its combat capabilities. According to a white paper from Lockheed Martin, the Helios system has shown it can accurately hit fast-moving targets at long ranges. It was able to complete its targeting process using data from the Aegis combat sensor, after first tracking the target with both coarse and precise optical methods. The optical dazzling interdictor Navy is used in the system to interfere with enemy sensors by disrupting their electro-optical and infrared systems. While similar technology is found on other ships, the Helios program is the first to fully integrate this capability into a ship's command and control system. The laser weapon also includes a surveillance mission alongside its laser destruction and dazzling functions. The spokesperson chose not to disclose details about how its surveillance capabilities are being tested. They mentioned that the Helios is a multi-mission laser weapon system, and its missions, including surveillance, will develop over time as the Navy carries out at-sea operations and refines tactics, training, and procedures for this new capability. It's still unclear how the weapon will be used at sea. When asked if the Navy plans to install the laser on other ships, Lockheed Martin spokesperson didn't provide details. They, however, stated that the system can be adapted and used on other types of ships and combat systems. The Navy is interested in using laser weapons on different ships. Last year, they tested another laser system, the solid-state laser, technology maturation laser weapon system demonstrator, on the USS Portland. This system successfully disabled a drone during a sea test in 2023, proving the success of the laser systems on aircraft carriers. Now that the Helios system is ready, the next process involved the installation of the system through its paces after installation, with at-sea testing that was scheduled to start in 2023. The spokesperson noted that the Navy will gain valuable insights into the use of the Helios system in real maritime operations that started last year, and these lessons will guide future development efforts. They also mentioned that the laser completed land-based testing earlier this year in Wallops Island, Virginia. The main challenge ahead for the program will be integrating the system into the Navy's layered defense. They stated that integrating the laser into both the ship and its combat system, as well as ensuring its suitability for maritime conditions, is crucial for effective directed energy warfare. The system must function as a key part of a layered defense setup, like the Aegis combat system on DDG-51 class destroyers, and fit within the ship's space, weight, and power limits. While the laser is designed to meet these requirements for Arleigh-Burke-class ships, it would need to be adapted for other ship types or different combat systems. They added that its scalable and modular design architecture allows for such adjustments. According to the white paper, the system could be scaled up to 120 kilowatts or more, depending on the space and power limits of the ship. This includes potential future ships like the Constellation-class frigates and the next-generation guided missile destroyer, DDG-X. Sauer mentioned that the Navy is the most likely starting point for deploying laser weapon systems in the U.S. military because naval ships have ample energy supplies. However, he noted that fitting the laser on smaller ships presents significant challenges due to space and power constraints. As the United States develops laser technology, its rivals are also advancing. Although China and Russia don't currently have advanced laser systems like those in the US, lasers might become more common in various areas in the coming years, according to Mick Ryan from the Center for Strategic and International Studies. Ryan mentioned that while installing lasers on ships is happening now, seeing them used on land might take a bit longer. He also pointed out that Russia has claimed to use an experimental laser system called Zadira in Ukraine, though it's doubtful it has had a significant impact, as Russia often exaggerates its technology. However, the use of unmanned aerial systems in the conflict will likely drive technological progress. The Navy's laser weapon, along with other directed energy technologies from the Pentagon, like the Army's Directed Energy Maneuver Short-Range Air Defense System, can send a clear message to potential enemies, he explained. He added that the goal is to deter adversaries with these advanced technologies. However, if deterrence fails and a fight is necessary, it's important that these systems are effective in combat. However, the United States is not the only technologically advanced nation investing into the development of laser systems. Chinese defense officials are working on a Star Wars-style laser weapon for their nuclear submarines designed to shoot down British and US spy satellites while staying hidden underwater. Chinese scientists revealed that the laser can destroy satellites and enemy aircraft in an instant because it fires at the speed of light. One of the targets they have in mind is the SpaceX Starlink satellite system, which can often be seen passing over the UK. The UK relies on about 7 military satellites for global command and control, while the US has 247 orbiting satellites. These plans were shared in the Chinese defense magazine Command, Control, and Simulation, where researchers explained that the laser could be mounted on a mast and fired at satellites, while the submarine remained underwater. The article explained that a submarine equipped with a megawatt-class solid-state laser could stay underwater while raising a retractable mast to fire at satellites, then dive back down after the attack. It stated that once a satellite is within range, the laser is activated, and after the strike, the submarine can submerge again and either wait for its next mission or return to port. Chinese sources claim that a laser would be much more effective than current anti-satellite weapons, which use ground-launched missiles with explosive warheads. The Chinese document also mentioned that the Starlink satellite network is dense and resilient, with many small satellites. Even if a large number are destroyed, replacements can quickly take over, making missile attacks inefficient. The article reported that satellite swarms are becoming vital in warfare, as seen in Ukraine, where they helped maintain communication for its forces after regular internet and satellite systems were destroyed. This highlights the need to destroy or disable many small satellites in low Earth orbit. China believes the answer lies in deploying fleets of mass-produced laser-equipped submarines, which could be sent to oceans worldwide to target these satellites. These laser subs could also help protect China's ballistic missile submarines from detection. The article explained that an escort submarine could use its laser weapon to disrupt or destroy enemy satellites, making it harder for space-based surveillance to track missile launches and thus keeping them hidden. However, some experts argue that developing a nuclear-powered laser submarine could still take many years. Chris Carlson, a former naval analyst for the Defense Intelligence Agency, explained that a submarine at periscope depth is not a stable platform for firing. He said that even a small movement in the submarine's position could cause the laser beam to miss the target. Carlson added that communication with a submerged submarine is challenging. After receiving an alert, the submarine would need to raise a mast with a data link to connect to the tracking sensor. Then, a separate tracking laser would need to find the target and aim the laser weapon correctly. He pointed out that many things could go wrong in this process. After several years of intense development, the United States has finally revealed its mind-blowing aircraft with capabilities that have blurred the line between reality and fiction. This secret aircraft is unlike anything the world has ever seen before, sparking intense interest and curiosity across the globe. With an exceptional speed that is more than 5 times the speed of sound, lethal armaments that aim with precision and agility that makes it unrivaled, this aircraft is ready to dominate the skies. What are the capabilities of this new aircraft? What exactly makes it special? Join us as we explore the features of the U.S. secret UFO fighter that has shocked the world with its unbeatable speed. To remain at the forefront of technological advancement, the United States Air Force has continuously invested billions of dollars into the creation of aircraft with capabilities that will most likely dominate the skies. These new fighters are so unique that the world is in awe as the U.S. gives a snippet of what's to come. Let's begin with the capabilities of some of the most renowned aircraft that promise to revolutionize the skies, beginning with the sophisticated 6th-generation airfighter. The plan to develop this new stealth fighter, the United States Air Force's Next Generation Air Dominance, or NGAD program, began in 2014. With an investment of $16 billion, the NGAD fighter is expected to lead the way in 6th-generation aircraft, excelling in speed, altitude, stealth, and advanced technology. The NGAD program, which was initially inspired by the quick development cycles of 1950s and 1960s fighter jets, has shifted to a more traditional development model due to the complexity of modern aircraft design. Now, to its capabilities, this next-generation fighter can reach speeds of up to 1,800 miles per hour, allowing for quick responses and entry or exit from hostile areas. It can operate at a flight ceiling of 15 miles, where few enemies can reach it, giving it a major advantage. But that's not all about this sophisticated aircraft. Its stealth technology is highly advanced, making it nearly invisible to radar and hard for enemies to track. This allows the NGAD to perform covert operations and strike precisely. The fighter also makes use of advanced artificial intelligence for autonomy and decision-making. It can control a swarm of drones, enhancing its versatility. These drones come in 2 types: reconnaissance drones with precise radars that can cover a large area, and offensive drones with advanced weapons that can quickly neutralize targets. The integration of AI with these drones improves the fighter's awareness and effectiveness in combat. The NGAD is one of many advanced aircraft the USAF is developing. One key feature of the NGAD is its ability to have different versions tailored for specific missions, such as long-range operations in the Indo-Pacific and shorter missions in Europe. These aircraft will use advanced engines from programs like the Adaptive Engine Transition Program and Next Generation Adaptive Propulsion, with engines expected to be ready by 2025. General Brown from the U.S. Air Force revealed that the NGAD will gradually replace the F-22 as new units become available. Originally planned as a single aircraft type, the NGAD now includes several systems, with a core manned fighter complemented by drones and advanced computer systems to improve its effectiveness. The goal is to start deploying these fighters by the 2030s, depending on production rates. To make this possible, technologies from the F-22 are helping with NGAD advancements. In June 2022, the U.S. Air Force approved key technologies for the next phase of development. The prototypes were tested under the AIIX plane program, with 3 different versions evaluated by 2023. Proposals were requested in May 2023, with a partner company expected to be chosen by 2024. This aircraft aims to achieve air dominance by integrating manned and unmanned aircraft with advanced cyber and electronic systems. It represents a major advancement in aerial warfare and signals increased global competition in advanced fighters. The NGAD will have a sophisticated computer system for mission planning and post-flight debriefing, improving pilot efficiency. It will also feature enhanced communication systems for better coordination with other aircraft and ground personnel. The propulsion system will offer high speeds when needed and fuel efficiency during slower operations, making it a significant upgrade over current fighters. Boeing, another aviation powerhouse, has made headlines with its FA-XX concept for a 6th-generation fighter. This sleek twin-engine jet featured no tail and a futuristic 2-seat cockpit, designed to be both manned and unmanned. With a weight class around 40,000 pounds, it was a bold step forward in stealth technology. Boeing even considered the Northrop Grumman X-47B, known from the UCAS-D program, as a possible contender. In a later update, the FAX retained its tailless, stealthy design and added canards for improved maneuverability. It incorporated advanced features like diverterless supersonic inlets, similar to those on the F-35, and had limited rear visibility, relying on cutting-edge sensors. As the Department of Defense explored replacing older F/A-18 Hornets, the Navy evaluated several paths, including acquiring more F-35s or developing a new aircraft. The FAX was part of this exploration, with an analysis aimed at assessing new aircraft options and advancements in technology. By the time the Navy moved into developing the FAX concept, budget concerns emerged. Speculation arose that the FAX might end up being an enhanced version of existing fighters like the F-35 or Super Hornet. Much of the FAX's details were kept secret under a classified program known as Link Plumeria. Facing financial constraints, the Navy proposed delaying the FAX to prioritize immediate needs. Another aircraft with unbelievable capabilities that would boost the U.S. dominance is the Quarter-Horse. Hermes has just revealed its new high-speed jet-powered Quarter-Horse Mk-1 aircraft, bringing the Atlanta-based startup closer to its goal of creating the world's first reusable hypersonic plane. The unmanned Mk-1 is set to be the first Hermes aircraft to fly and test at Edwards Air Force Base later this year, to show it can safely take off and land at high speeds. Hermes plans to develop two types of hypersonic aircraft, a multi-mission drone called Dark Horse for defense, and a passenger plane named Halcyon that could travel from New York to London in just 90 minutes. This aviation company has launched the Quarter-Horse Mk-1 and plans to pitch the next version, the faster supersonic Mk-2, which is scheduled to be released in 2020, to the Pentagon. The founder and CEO, A.J. Piplica, stated that the new capability would address specific needs and that having it operational a few years before the Dark Horse would be beneficial for the Pentagon. Piplica did not comment on whether the company would propose the Quarter-Horse Mk-2 for the Pentagon's Replicator program, which aims to deploy thousands of unmanned systems, or the Air Force's Collaborative Combat Aircraft program, which seeks to develop autonomous drones. However, Hermes is not among the initial 5 companies participating in the early stages of the Air Force's Collaborative Combat Aircraft project. This aviation company sees the Quarter-Horse Mk-2, which it calls the world's first purpose-built Mach drone, as a unique addition compared to current U.S. military drones like the RQ-4 Global Hawk and MQ-9 Reaper, which fly at slower speeds. Interestingly, Hermes isn't alone in exploring high-speed unmanned aircraft. Recently, the startup Enduro introduced a rocket-powered platform designed for air defense, and Stratolaunch plans to test its own recoverable hypersonic vehicle later this year. The company plans to build 4 Quarter-Horse test vehicles as a step toward developing hypersonic aircraft that travel faster than Mach 5. They also aim to produce the Mach 3, which its executives claim will exceed the Mach 3.3 speeds of the famous SR-71 spy plane made by Lockheed Martin. At the same time, Hermes is working on the Chimera 2 propulsion system, which will be tested on the Quarter-Horse Mk-3 and used in mass production for the Dark Horse. According to Piplica, the Chimera 2 will be based on a Pratt & Whitney F100 engine, but will feature a ramjet afterburner instead of a traditional afterburner, along with a custom-made pre-cooler and bypass system. The Mach-1 aircraft, which uses a General Electric J85 engine and is controlled remotely, is a subsonic plane. It will undergo various tests including subsystems, ground station, operations, and human factors before its first flight later this year. Piplica noted that Hermes originally aimed to get a plane in the air by 2023, but decided to do extra testing with the Quarter-Horse Mk-0, which completed remote taxi tests in November. For the Mk-1, Piplica mentioned that the requirements were set in September of the previous year and that it is being unveiled about 200 days later, noting that this development speed is unusually fast for the country. Next year's Mk-2 aircraft will use the F100 engine found in the F-15 and F-16, allowing it to fly at supersonic speeds. The engine will be upgraded with a Hermes-built pre-cooler to achieve faster speeds than the F-100 current capabilities. but the full Chimera II engine won't be used until the Mk3. Piplica mentioned that Hermes could produce about a dozen Mk2 drones annually at its Atlanta facility, but will need to expand if there is strong interest from the Defense Department. In the meantime, the company is working on supply chain partnerships to support Mk2 production if the Pentagon becomes a customer. The Defense Department hasn't officially announced a hypersonic aircraft program, but it has invested in Hermes while it develops the quarter horse. In 2021, the Air Force gave Hermes a 3-year, $60 million contract to build and test 3 quarter-horse aircraft and a reusable hypersonic propulsion system. At that time, Air Force officials suggested that a commercial hypersonic aircraft might be useful for military transport or surveillance. Under a contract signed last November with the Pentagon's Defense Innovation Unit, the quarter horse will be involved in tests for the HyCat initiative, which aims to improve high-speed flight testing. In 2022, RTX's venture capital branch also announced it would invest an undisclosed amount in Hermes. The Defense Department is interested in reusable hypersonic aircraft because they could enable the U.S. military to carry out surveillance and strike missions much more quickly than the current bomber fleet, according to James Weber, the department's principal director for hypersonics, during a recent congressional hearing. However, he noted that there is still a lot of work needed in science and technology to develop the materials and structures needed for these reusable hypersonic aircraft. While Hermes claims that the quarter horse exceeds the capabilities of the renowned SR-91, the question remains which is more advanced and lethal between the quarter horse and the successor of the SR-71. This brings us to the son of Blackbird. The U.S. Air Force is presently working hard to develop the SR-72, which they've called the son of Blackbird. This aircraft has gained almost legendary status since it was first shown in the 2022 film Top Gun: Maverick, where a fictional version called Dark Star appeared. If successful, the SR-72 will be a hypersonic surveillance plane that combines unmatched speed and stealth. The SR-72 was first mentioned in 2007 when it was reported that Lockheed Martin was developing a new, super-fast aircraft to replace the retired SR-71. The SR-72 was said to be able to exceed Mach 6, which is over 6,000 to 400 kilometers per hour, making it twice as fast as the SR-71. While it was designed for the U.S. Air Force, no official details were released, though some concept art and information leaked over time. Initially, the Air Force did not confirm whether Lockheed Martin had discussed the SR-72 with them. In 2012, reports suggested that the U.S. had decided not to fund the SR-72 program, leaving it unclear whether the Air Force had approved the development of a prototype. However, Lockheed Martin has since confirmed that they are working on the SR-72, and a prototype may be in the works. Brad Leland, the hypersonics program manager at Lockheed Martin, has led the project and provided updates on its progress. He revealed that this advanced hypersonic aircraft will use a turbine-based combined cycle propulsion system, which combines a turbojet for slower speeds with a powerful ramjet or scramjet for hypersonic speeds. The aircraft is designed to have a smaller radar profile, making it more stealthy. The Air Force wanted a new reconnaissance aircraft with advanced long-range surveillance capabilities. While the SR-72 Blackbird was known for its speed, the SR-72 is expected to have much better stealth features. Improvements in anti-aircraft technology, like faster missiles and improved radar, have reduced the SR-70's advantages. The Air Force believes there is a strong need for a faster reconnaissance aircraft, potentially exceeding Mach 6, that also uses stealth. If it reaches Mach 6, or over 4,000 miles per hour, it would greatly improve intelligence gathering and reduce the risk of being shot down, as most aircraft can't catch something moving that fast. However, the SR-72 offers more than just reconnaissance, which sets it apart from the SR-71. The Air Force is thinking about equipping the SR-72 with weapons, making it a high-speed strike aircraft. This new plan for the SR-72 is different from the SR-71, as it could be used for quick strikes in urgent missions or long-range counterterrorism operations. If a conflict arises and traditional U.S. military forces are limited in the Indo-Pacific region, a group of SR-72s could be very valuable until China's advanced defense systems can be overcome. In today's world, American deterrence is largely ineffective. Rebuilding it will be challenging with multiple strong competitors. However, it's possible by creating fear among America's rivals. This fear would come from the idea that the U.S. could strike from anywhere at any time, delivering powerful payloads to unexpected targets. The threat would also include delivery systems that could be deep in enemy territory and vanish before being detected, making detection pointless. This aircraft is far more advanced and necessary for the Air Force than the proposed next-generation air dominance warplane. By pushing the limits of aeronautical engineering, the Air Force will gain significant benefits and innovation in the future. The aircraft is not just another reconnaissance plane or a waste of resources. It is a fast attack aircraft capable of entering restricted airspace and changing the nature of the battlefield. It will help restore some of the deterrence the U.S. has lost over the past 20 years. This aircraft is essential for the Air Force. Aside from aircraft, the United States is also investing in a lethal bomber that would work alongside the legendary B-52 Stratofortress, the B-21. With a massive investment of $630 million, 7 years of dedicated work, and over 25 years of dominance, the U.S. strategic bomber has become a formidable force. The B-21 Raider stands out with its unique features, making it unmatched in comparison to other bombers like China's new Jian H-20. Let's dive into the details. The B-21 Raider is a new bomber developed for the U.S. Air Force under the Long-Range Strike Bomber program. Its goal is to replace older bombers with a next-generation aircraft that can fly long distances, stay hidden with stealth technology, and carry various types of weapons, including powerful ones like nuclear bombs. In terms of avionics, the B-21 will have advanced systems including multifunctional radar, digital navigation combining radar and GPS, and sophisticated sensors. Communication is a priority, with systems for coordinating with other aircraft and ground forces, as well as danger avoidance features to protect the crew and aircraft. The B-21 is expected to carry over 30,000 pounds of weapons, including nuclear bombs, long-range missiles, and conventional bombs, making it suitable for various combat scenarios. However, specific details about its range, weaponry, and size remain classified. Photos of the B-21 were released in December 2022, giving some insights but leaving many details speculative. The B-21 will be based at Tinker Air Force Base in Oklahoma, with testing at Edwards Air Force Base in California. It will operate from several bases, including Dyess, Ellsworth, and Whiteman Air Force bases, with Ellsworth being the first base. There were discussions about using a drone with the B-21, but the idea was dropped to save costs. The Air Force also plans to acquire a new fighter jet to protect the B-21 on missions. As the world's first sixth-generation bomber, the Raider represents a major leap in aircraft technology, similar to the sixth-generation NGAD fighter still in development. The program started in 2011, sparking fierce competition among aerospace giants Boeing, Lockheed Martin, and Northrop Grumman. After 4 years of competition, Northrop Grumman won the contract due to its experience with stealth bombers and a cost-effective proposal. Cost was a crucial factor, especially given the high expenses of the B-2 bomber. The B-21 Raider aims to be more affordable, costing about 68% less than the B-2 while offering advanced capabilities. To keep costs down, Northrop Grumman collaborated with around 400 suppliers across 40 states, including top companies like Pratt & Whitney, BAE Systems, Spirit AeroSystems, Orbital ATK, Rockwell Collins, GKN Aerospace, and Janicki Industries. Together, these companies have developed the Raider, a bomber that, despite benefiting from decades of technological advances, remains a powerful and cost-effective military aircraft. The Air Force plans to acquire at least 100 B-21 Raiders, with the possibility of up to 145 if the bomber performs well in tests. Once operational, the B-21 will initially work alongside other bombers like the B-52, B-1, and B-2. Eventually, it will replace these older models, marking a shift in the bomber fleet. The B-21 Raider aims to showcase U.S. military power globally, with capabilities comparable to modern naval ships and advanced nuclear weapons. The goal is to modernize the bomber fleet and nuclear weapons for operations in the Indo-Pacific, especially in response to China's activities. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.